Start. I am S.KIRUTHIKA, final year MCA. My project title is Unsupervised Anomaly Detection in Network Knowledge Based Strategy using Clustering. Abstract. The traffic monitoring for detection of network attack is based on an acquired knowledge perspective. Current techniques detect either the well-known attacks on which they are programmed to alert or those anomalous events that deviate from a known normal operation profile or behavior. Existing system. The objective of clustering is to partition a set of unlabeled elements into homogeneous groups of similar characteristics based on some similarity measure. Different from other techniques for unsupervised data analysis, clustering permits us to work with multiple class problems without modifying the characteristics of the analyzed traffic. Disadvantage of existing system is the major drawbacks in current cluster analysis techniques, the lack of robustness. Proposed system. The information provided by the multi-clustering approach to characterize an unidentified group of malicious flows, automatically producing easy to interpret signatures of the attack. Software requirements and hardware requirements. Front-end Java, tools NetBeans 7.0, OS Windows XP. Hardware requirements, system Pentium 2.4 GHz, hard disk 40 GB. System architecture. The system architecture, we are using two algorithms, single cluster algorithms and multiple cluster algorithms. Single cluster algorithms, the sender will send the message to the receiver by using node 1, node 2, node 3. Multiple clustering algorithm, the sender will send the message to the receiver by using node 1, node 2, node 3, but it will show the attacks. Who will find out the error? System design, use case diagram, sequence diagram, collaboration diagram, activity diagram, data diagram. Modules. Feature detector, the detector doing the function of capturing images. The conventional and most widely used approach to speed up the feature detector is to use approximated filters. Feature detector handles to detect the images while capturing the image or picture. The most widely used approach to speed up the feature detector is to use approximated filters. Tracking and recognition. Tracking and recognition means to achieve real-time object recognition on platforms with limited resources. This feature descriptor is used for both tracking features and object recognition, unlike most work where two separate feature descriptors are used. Dynamic length descriptor is that implementing an incremental version of the descriptor is very easy while the descriptor is also very fast. Adaptive sampling. Compress the image, low memory and high efficiency for embedded systems. Pixels are calculated and compressed using the adaptive sampling algorithm. It will reduce the amount of data that should be processed while obtaining visually the same output as when the image is processed exhaustively. The last one is time detector. It will reduce the time consuming for capturing image. The speed of fast is due to its overall simplicity, assisted by careful ordering of the comparison. Using this concept of adaptive sampling outlined above, it is possible to modify detector algorithm. The node connection. The sender will send the message to the receiver by using node 1, node 2, node 3. Sender and receiver view system. It will send the message to the sender to the receiver by using node 1, node 2, node 3. The node 1 denotes the forwarding to the message, destination message and message translation. If the sender will send the message hi, it will receive the message, then it also capture the images or files. Conclusion. Feature detection is central to the visual processing pipeline. Recent effort in improving speed performance has concentrated on approximations to the filters. Thank you.